Hi, my name is Jordan Buford. I'm part of the AutoCard group with Efine and Ray. And basically, we devised a car that can drive itself using OpenCV for lane detection, or optionally a PlayStation controller for user control. Personally, I took the part of processing and interfacing the commands from the PlayStation controller and sending those commands over UART to our FPGA. We all kind of worked on system integration. I also had a few extra parts like LEDs. I helped integrate those with GPIO and kind of the user control logic. The instructions to optionally have lane detection on or off. And next, Efine will talk to you about what you did.
So I'm responsible to do the Raspberry Pi part. So it has two main functions. One is OpenCV, which is used to do lane detection, and the other part is the ultrasonic sensor, which sends the object in our road and send a stop command if it sees an object.
My name's Hui, and I took part in the PWM signals mainly, and start the project and start putting files and configure out hardware stuff, and configure the hardware timers, software timers for module and servo PWMs, and also the feedback control functions and the manual control functions for controlling those two PWM signals, and also wiring all the parts together to the car, and with help with Jordan with the UART and also the communication to all of those parts and integration them together, and also the debugging part. Yeah.
Put to the oscilloscope.
That was on the drill bits.
So something that was difficult for me personally was the Bluetooth communication. It was kind of going too fast. I had to come up with a way around that. I chose to encode our data separately into data and instruction bytes.
So we tried different kinds of communication. At first, we are trying to use SPI, but we have issue setting up a Smart Fusion as slave. We tried I2C, it doesn't work, and we tried UART, it works, but it's only on the UART pin. So later I found out I can set GPIO up as UART, and then we solved that problem.
The problem we had is first we need to assemble the servo and module into a car, and it's very hard, and the size doesn't fit to very exactly the same. And second, it's very hard to change the PWM signals based on the lane detection inputs. And so I use a feedback control based on the current deviation, previous deviation, and change the next period of the PWM signals. And when it comes to the next period, it will change the current period based on next period. So that problem fixed. So after that, we could change the PWM signals based on the deviation inputs from the lane detections.
During our project, we ran into quite a few problems, and even though it didn't come together in the end, all the parts did work independently. One of the major problems we had was the Smart Fusion FPGA kind of just not behaving correctly. So we lost many hours trying to debug the FPGA when the debugger just simply wasn't working. So a lot of sporadic behavior on that part. Another issue we had was with the chassis actually, so more of a mechanical thing. But we didn't know because when we were testing, we tested all the components outside of the chassis, but when it came time to put everything into the chassis, our car wouldn't move on the ground. It would only move while suspended. So from the small amount of experience that we have, We think it might be a mechanical issue with like the differential slipping on the drivetrain. We're not entirely sure, but we did check the amperage on the DC motor, and it was correct. The motor needed a certain voltage above like 3 volts while having a load, so it was all working correctly, and that happened at the last minute. And one more thing that happened right before our demo, our Bluetooth module died on us, so that was a bit unfortunate, but we did learn a lot in this project and we had a lot of fun.